about continuity, and we're going to talk more about continuity. We're going to look at some of the homework questions here. Here is our first graph, and you can see it's one of these broken shapes, and you've seen them before. And we're going to be looking at similar questions, at least at the start of today, compared to yesterday. I'm going to ask you the questions, maybe phrased in a slightly different way. Give me the x coordinates of any point in that graph which is not continuous. Give me the x coordinate of any point in that graph that is not continuous.
-1.
Agreed. We would call that what, a vertical, right? Discontinuity. Give me another one.
0.
Okay, what would we call that kind of discontinuity? What would you call the one at x equals 0? It has a name.
A jump.
Yeah, jump discontinuity. I like names that kind of make me think of it, right? What's happening at x equals -2? Because that is a discontinuity, isn't it? What do we call those kind?
Removable.
Right. So when someone says there's a removable discontinuity at x equals -2, even if you didn't see the picture, could you have a mental idea of roughly what it looks like? There'd be a nice wee curved bit of hole there, right? Does it help that hole at x equals -2 if I put a little dot, which is basically the value of the function, somewhere above it? Would it help it in any way, or would it still be discontinuous?
It would still be discontinuous.
Right. Right? You can't fix it. In fact, the only way you could fix that one would be to put the solid dot in the hole. In other words, fill up the hole, right? Do you remember my little story about traveling from left to right, and if you get killed, it's discontinuous? Remember a way of phrasing that? So if you were doing x equals 0, can you see as you travel from left to right, you'd get killed because you'd fall off the edge? And if you were at x equals 1, would you agree if you traveled, wouldn't you just fall off the edge and die? And the vertical asymptote, wouldn't you fall through a hole in the ground and get killed at the center of the earth? So I think that's a good, simple way to do that. Now, let's look at how they phrase the same thing. For which value or values of x does this function, which is called g of x, approach a different number from the right as it does from the left? Now, a different number from the right as it does from the left. You see, coming in from the right, it gets to here. Coming in from the left, it gets to here. So I would call that one of those answers. Is there another one? There is one more. Where's the other one in that shape where coming in from the left is a different number than you would get if you came in from the right? It's basically right and left limits, but they're not calling it that.
Well,
There isn't, exactly. Would you count x equals -1 in that story? Is it coming in as a different number as you come in from the left or the right at x equals -1? Would you say that belongs in the list?
No, I don't think
No.
so.
No. Now, if this side here went up the way and this side went down the way, then wouldn't you include it in the list? You know, if it went down on this side and woof up on that side, you know, one of those things that do that kind of thing, then I would say it, right? Now, for which values of x belonging to this function increase or decrease without bound? Oh, there's a fancy way. What one are they talking about here? Increases or decreases without bound? Sounds like an old English story.
-1, where it
Right.
goes to -infinity.
Right. See how they phrase that? It's not that you don't know the answer, you're just maybe not sure what they're getting at because of the way they phrased it, right? If somebody had said to you, where is it a vertical asymptote? You'd say, oh, I know it. Right? Or where did it go vertical? Or where did it go infinite? Wouldn't you actually probably know better what they're asking about? But they said without bound, you have to think, what's that? Well, now you know, right? So next time it won't be a problem. Now, from the given graph of G, state the numbers at which it is discontinuous. And it talks this thing about a comma separated list. So we decided -2, -1, 0, and 1. So the way that would work is -2, comma, I think it was -1, comma, 0, comma, 1. I think that was the 4 numbers. I should check, shouldn't I? -2, -1, 0, 1. Yeah. A comma separated list is that, right? You just write the 4 answers down with commas. Okay, in case you're wondering what the heck that was. I hope that it will allow you to put little spaces in and not be annoyed at your answer. I would, well, at least I would hope that it would allow that, right? But you'll find out. If you put it in and it doesn't like it, you know, because you put spaces in, just don't put spaces from now on. And I don't know why it's telling me that, because I don't want to know the answers. Oh, because I had the solution thing on. Excuse me. Right, now we're going to look at another graph. And we could talk all about left continuous and right continuous and so on, but what we want to do is answer their questions. So the first question that they come up with says, at what numbers, because it could be more than one, does the overall limit not exist? Now, when I look at this shape, I can only see 2 places. Would you agree x equals 1, something weird is happening? And would you agree at x equals 3, something weird is happening? With me so far? Now, these 2 guys, x equals 1 and x equals 3, are discontinuous. Wouldn't this one be a jump discontinuity, and wouldn't this one be a removable discontinuity? So far, so good. But oops, only one of these guys actually has the property that the overall limit does not exist. So which one? The guy at 1 or the guy at 3? Which one does not have an overall limit?
1.
At 3?
Well, I
3.
hear both answers, 1 or 3, right? Let's do the both and tell you why it's 1. Or right, if you do 1, isn't the left limit, I'll pretend that's 2, and wouldn't you agree the right limit is 1? Would you agree these are different numbers? Right, that's why that's the right answer. If I asked you for the overall limit here, isn't it that guy there? Whatever that height is. But you might say, but that's a dot and that dot's different from that. Doesn't the point where the dot is have no effect on the value of a limit? The limit doesn't care if that dot is there or not. Won't the overall limit be the same number coming in from the left as coming in from the right? So that's why in this case, that's the only one that does not have it. Now, it then goes on and asks us for what numbers is it not continuous? Now, in this case, 1 and x equals 3, or we're calling it a, but it's 1 and 3. Would you agree that both of these are not continuous for different reasons, but they're not continuous? So do you see there's a difference between the answer to A and the answer to B, right? The overall limit is not the same numbers all the time as where you're discontinuous. So very often they share answers, but they're not always the same answers, right? At what numbers does this function exist, but f is not continuous at A? Well, it's not continuous at 3, right? But doesn't the overall limit exist? So they were wanting you to put in 3 there. Do you see how they've separated it from that guy, the overall limit doesn't exist. This guy, the overall limit does exist, but both of them are not continuous. I mean, that's, I think, what they were thinking when they created that question, right? To try and get you to separate what an overall limit existing means and what discontinuity means, right? Because they're not exactly the same thing, right? You can be one without being the other, right? Same basic question here, but a little bit kind of different shape to it. If you look at this particular diagram, I think I could make it a little bit bigger. At what numbers does the overall limit not exist?
One.
I think I heard 1.
1 and 5.
All right. 1. Agreed. Now, so 5. I'm not sure where 5 came from. 1, 2, 3, 4. Oh, down here. Oh, yeah, you caught it and I missed it. There you go. I missed that little thing there. Yeah. Did you agree 1 and 5 have a problem? Right. Isn't 1 a vertical discontinuity as well? And isn't 5 a jump discontinuity? But we're not talking about continuities. We're just saying the limit doesn't exist. Now, you might say, but isn't that limit plus infinity? Well, yes, it is. But is plus infinity a number? And so if you argue it that way, it doesn't have a limit, right? Although sometimes they're flexible in that. If you notice, sometimes you do put in infinity as an answer. So you have to kind of do context. Now, at what numbers is this function not continuous? Would you agree 1, 3, and 5? Now, at what numbers does the overall limit exist, but f is not continuous? In fact, see whenever they ask you that question, aren't they always asking you for where the removable discontinuities are? Isn't that the only time you're going to have the limit existing but discontinuous? Isn't that going to be a removable discontinuity? So now I've seen that a couple of times. That is the removable discontinuity, which happens to be at 3. And there's some more pictures. Oh, these ones are a little bit different. So I'm going to show you what is going on here, or at least I'll try to. Someone today asked me, and I think it was a good idea, to change things a little bit. See if you can notice. Do you notice anything different about my whiteboard today compared to normal? No? Have you noticed that on the right-hand side, my little face and head is not covering the top right-hand corner of the paper, and so you can't see what's underneath it? You see that? Yeah. I don't quite see what you see, so it was nice that they told me that. So hopefully when you watch the video, you won't have this stupid block up here that I'm writing on top of and you can't see it, even though I can see it right now. So suppose I tell you I want a shape to have the following features: a jump discontinuity at x equals 3, a removable discontinuity at x equals 1. And I said, I want you to draw a sketch that has these 2 features. There are literally an infinite number of correct answers. Right, at x equals 1, I want a removable discontinuity. Couldn't I do that? You agree? Isn't that what a removable discontinuity at x equals 1 looks like? Now, I want a jump discontinuity at 3. Couldn't I do that? Would you agree that has all the features that we want? Would you agree that there are many graphs that have that same feature, right? Couldn't you do all sorts of different versions of it? I mean, just right now, couldn't I put a dot there, and wouldn't that be a slightly different version of the one I had? But couldn't I have this piece up there? Couldn't I have this pointing down the way and this piece up there? Couldn't I do all sorts of things? So if you get a question and it says, sketch a guy with this feature, as you're about to see now, because I'm returning back to the homework, because it's very visual today, so I have to kind of show you what the heck's going on. You want a jump discontinuity at x equals 7. Whoops. And you want a removable discontinuity at 5. And you might say, well, how am I going to do the answer? Because there's an infinite number of possible ones. You are only allowed to pick from this list. So one of these 4 pictures has a removable discontinuity at x equals 5 and a jump discontinuity at x equals 7, right? So that's picture 1, there's picture 2, there's picture 3, and there's picture 4. Okay, which one of these is the only one that fits? A jump discontinuity at 7 and a removable at 5.
First one.
Do you agree that's got a removable there and a jump there? Would you agree this one's no good because aren't both of them jump? Would you agree this one's no good because aren't they both removable? And isn't this one no good because that guy is a jump and it should be removable, and that's a removable and it should be a jump? So basically in this question, does it make sense that you just pick the one that fits? Okay, is that question a little bit clearer now when you see how you would approach it? So you just put a little dot on the guy that works. And there's another one, same idea. Here's another one, the same idea. And let's look at these fellas. Which of the following are continuous functions? So you got to imagine what these would be. So the temperature at a specific location as a function of time. So the x-axis is 1 p.m., 2 p.m., 3 p.m., and the y-axis is the temperature. Would that be a continuous function?
Yes.
Yeah.
Yes.
Temperatures don't jump from 14 to 15, don't they? Start at 14 and then they climb up slowly to 15, right? What about the temperature at a specific time as a function of the distance due west of New York? So you're 10 miles away from New York, what's the temperature? You're 20 miles away from New York going west, what's the temperature? Can you imagine that guy? Would that be continuous?
Yes.
Yes. The altitude above sea level. Ooh, I better read this one again. The altitude above sea level as a function of the distance due west. So I'm 20 miles west of New York and I'm 500 feet up. 100 miles west and now 110 feet up, that kind of thing. Would that be continuous?
No.
No.
I'm thinking I could do a no. Couldn't you hit a cliff? And couldn't at one point you're 200 feet and then whoop, you're now at 400 feet because it's a vertical cliff. Can you imagine? At least theoretically, couldn't there be a cliff? So I'm going to not pick that one. The cost of a taxi ride as a function of the distance traveled. I could argue both ways on this one. So how much it cost and the distance, right? You went 2 miles, you went 3 miles, you went 4 miles. Right. Do you think that would be a continuous function? I think it's not.
I feel like this is just so subjective.
It is. It depends how the taxi
It's horrible.
charges you, right?
Yeah, because taxis will charge like X much up to this, and then like they'll change the rate.
Right, and that's what I'm thinking. So it's, you know, I'll make up numbers. It's $4 a mile, but once it's over 10 mile, I charge you $5 a mile, right? That kind of,
And then there's a charge just to get in the taxi. So it'll be-
and that's another jump. So if I was sketching that, wouldn't it probably be full of all sorts of jump discontinuities?
Yeah.
So that's why, that's what my gut feeling is. Now, if you say, oh, well, the taxis I get is a flat rate, right? It's $4 a mile. They don't charge you until you walk in the door and it's always $4 a mile. Well, if it was that kind of taxi, wouldn't the answer be, yeah, it's continuous? So I guess you'll find out when you're doing your answer, which one of those two. My gut feeling is that it's not considered continuous. Then have a current in the electric lights in a room. And then I guess that's a catch-all in case you think none of them. And Okay, time to look at continuity. And in this particular case, I'll pick my own. And we'll look at vertical asymptotes. Oh, I get something in the chat. Should I read it? Okay, Ron's got issues. I hear you, Ron. Right. We are interested in a fractional function. I'm going to pick this guy. And we are interested in it at a equals 2. And e equals 2, I don't like. I would prefer to just say x equals 2 because it means the same thing. We are interested in, is this function continuous or not continuous at x equals 2? Right. And they're going to ask us or tell us certain things, and we're going to say if they are true or not. And I've just killed that question by picking the wrong number. There we are. There's the first one. For this fractional function, does the overall limit as x tends to 2 does not exist? Is that true? If you got closer and closer to 2, would the left limit and the right limit be the same number? In fact, would they even be a number?
That would go to positive and negative infinity, right?
Right. So that does not exist is true. Agreed. The next box says f of -3 and, oh, damn it, I wish I'd unchanged my number. F of 2 and the limit, the overall limit as x tends to 2 of f of x are finite, which means they're just a number, but are not equal. Can you actually find the value of that function at 2?
No.
No, so I don't care what the rest says. That's not true, so I'm not even going to look at it any further. Here they have a left and a right limit. And the question says that the left and right limits are finite. And what else? But they're not equal. Would you agree in this case they are definitely not finite? They're infinite, aren't they? Wouldn't one of them be plus infinity and the other negative infinity? But they're not numbers. Finite, when you see that word, means it's a number, a real number. Infinite, right, is, you know, that guy. And then they go and they show you a picture. If you wanted to do a sketch of this function, you could certainly do it in your calculator, but I find that Desmos is just much nicer. Have you used Desmos, some of you? Let's go back and do a Desmos thing. I want to do a Desmos because I think pretty much all the answers I've just given are just going to be easier to see if you do Desmos. It's taken me a little while to open it up, so you could just bear with me. 151, here we go. And there's Desmos. Okay, right. Let's have a look at this function. So I'm going to type in y equals 1 divided by x take away 2. Isn't Desmos really nice where you just basically type it and you got the thing? And over here, can you see that vertical asymptote at x equals 2 that we kind of know? Right, now I've got that picture in front of me. Would you agree that the overall limit does not exist? You can see it in front of you. Would you agree that f of 2 doesn't exist? Would you agree that the left-right limit and the right limit are different from each other, but they're definitely not numbers? And any of the other questions that we just talked about, if I had that picture in front of me, I think it would be easier for me to answer. So I guess the moral of this story is that if you've got questions like this one in your homework, maybe you should look at the picture of it in Desmos, because it might help you to answer them. If you just look at the function as we did a few minutes ago, isn't it a little bit harder to tell what's going on when all you can see is 1 over x minus 2, right? You can't really visualize that, at least I can. Any questions so far? Are we good? Right. And they have a couple.
Ryan,
Yes, what's your
Sorry.
question?
a slow thinker here. So does the fact that it has a horizontal asymptote affect anything?
No, horizontal asymptotes are okay. Let me show you one. If I can draw a picture. I've lost my mouse. There we go. Gone back again. If you can remember your 141, vertical asymptotes cause problems, right? So would you agree there's a discontinuity there? It doesn't matter how I draw it, vertical asymptotes cause discontinuities. But can you imagine a function just flats lines as a horizontal, right? So maybe it curves up and goes like that on this side, right? Horizontal asymptotes do not cause discontinuities. Let's try and pick one. If I just, well, for SARS, doesn't that go on forever? If I just pick a random guy like at 7, would you agree that that function is totally okay at x equals 7, isn't it? If you were the little ant driving your car, wouldn't you be able to pass through 7 and not get killed? In fact, couldn't you just keep traveling along that until you died the old age? But that's not right. You're an ant that can live forever. Won't you be able to travel along that road and never die? But won't you get killed at x equals 2? Right? So
Yeah.
Discontinuities will kill you if you're a little ant driving a car. If you can travel along it because it's a curve, horizontal asymptotes, you can travel along them, they are totally okay. They cause no problems as far as continuity is concerned. So next guy I'm going to deal with is a function you've probably not seen in a while. So before we even worry about discontinuity, let's just talk about piecewise functions. Have you, do you recollect piecewise functions, that term? Let me show you one then. A piecewise function is a function where you describe it in terms of things like this. X squared plus 1 is the function, the rule that you use, but you only use it for x less than or equal to 1, and then it's 2x if x is greater than 1. That's what a piecewise function looks like. Does that ring some bells now that you've seen an example, even if you can't remember the name, right? Now, piecewise functions tend to, but not always, tend to cause discontinuities, right? And they almost always cause them at x equals 1. Do you see the boundary between these two? So if you were interested in, does this function have a problem, right? Does it have any value of x that's going to cause me trouble? Would you agree the only place where this is going to cause trouble is at x equals 1? Would you agree that's just a straight line and that's a curve, and straight lines and curves don't cause problems, right? So how do we decide if this is a problem? What you do is you find the value of the function at 1, which means you plug it into here, and that's 1 squared plus 1, which is 2. And then you find the value at this side. Now, technically speaking, I shouldn't be able to use x equals 1. So what I'm really doing is finding the limit as x tends to 1 from the right-hand side of this function. But for all intents and purposes, I can do a shortcut in that. Can't I just pretend that it is 1? Because I know that's what its limit is. Do you see these two guys are equal? That means this piecewise function is fine. There isn't any problem, even at x equals 1. If you sketched it, it would look something like this. What would x squared plus 1 look like? And it would look something like this. And okay, there'd be a funny little corner there, but isn't that okay? If you were a little car driving along there, wouldn't that be an awkward bend, but it wouldn't kill you? You agree? You could bend around the corner, you'd be safe. Now, if I change this story just a little, and I make this 2x plus 1 now, okay? Let's see what would happen to this new function. We use x squared plus 1 if x is less than or equal to 1, and we're going to use 2x plus 1 if x is greater than 1. And I'm going to use the trick that I can just evaluate the function at this boundary point. So this guy is still 2. And this guy, its limit at least, is 3. Do you see that they are different? And because they are different, you are going to get a jump discontinuity. Can you see that? Now, if I sketched it, it would look something like this. The y equals x squared would look just like it always did. It would look like that at 1. But the 2x plus 1 would, well, be a circle there. It would look like that. Can you see the jump discontinuity in my picture now? Does that make sense? Right. So you get a whole load of questions here about left limits and right limits. So let me just pick one of them. If I said to you, what's the left limit of this function going to be? And then I asked you what the right limit of this function would be. Make sure that that's a solid dot, and can I emphasize that as an open circle, right? So on this side, the answer would be 2, and wouldn't this side be 3? Haven't they essentially done what I just wrote up there? Do you see how it works? And if a left limit is not the same as a right limit, does it not mean you've got a discontinuity? And in this case, it would represent a jump discontinuity. Any questions about that? We good? Now let's look at a really horrible piecewise function that has, if that wasn't bad enough, this one has some extra problems. It's x squared take away 3x all over x squared take away 9. And you have to use that when x is not equal to 3. And you have to use the number 1 if x is equal to 3. Right. In this question, what value of x is going to cause the problem if there is going to be a problem at all?
-3.
Did you say negative or did you mean positive 3?
-3.
Oh, I wonder why you think, are you thinking that something bad happens here at -3?
-3 squared, 9 minus 9, 0.
Oh, but if you do -3, it'll be 9 add 9 on the top, not 0. It'll be 0 on the bottom. You're right. Ah, I got
You're
you.
dividing by 0.
Yeah, I got you. Yes, you are correct. Is there another place where there's a problem? Because what you said is correct. There is a problem at -3. Is there another value of x where there's an equal nasty problem?
Just 3.
Just 3, right? So let's focus on the 3 first, and then we'll go and look at your -3 and see what the problem is with that, because you're right, there is a problem. I didn't notice it until you explained it to me. So at x equals 3, let's see what we have. If I ask you to find the value of the function at 3, isn't it 1? Because that's what it tells me. If I find the overall limit as x tends to 3, I'm trying to find what this is trying to be. So we're now going to do some of that algebra we haven't done for a little while. Can you remember factor and cancel technique for finding overall limits? Remember factor and cancel method. Okay, how will I factor the top?
Factor out next.
Great. And how will I factor the bottom?
It's a perfect square.
Okay, so x plus 3, say x minus 3. There's the factoring. If I cancel, which typically comes directly after that, I now have the overall limit as x tends to 3 is just x over x plus 3. And that you can get because it ends up being eventually a half. Now, that guy is 1 and this guy is a half. Doesn't that mean that there is a problem at x equals 3? Agreed? What kind of problem do you think is happening in this case? Do you think it's a removable discontinuity that we've got or a jump discontinuity for this question?
Cool. It's just the 1 point.
So which one is it? A jump discontinuity or a removable discontinuity? What would that look like?
They're removable, I believe.
Okay, I agree. But would you agree it's quite hard to look at this and know what the heck the thing is, right? So what I'm going to do is hopefully I've still got Desmos up and running. Who knows with me, but oh, sugar and spice. Do you notice I don't swear much? I say sugar and spice when I get annoyed. And that was, you can blame that on me mum. I told you my dad was a coal miner. My dad could swear with the best of you. Right? It's a hard career, tough as nails, swore like a trooper. My mum never swore in her life. I was unfortunate enough, or fortunate, whatever way you want to think of it, to come from a very, I enjoy it, a large family. But the point was, they had a boy first, my brother Billy, and then they had 6 girls before they had me again. So I was brought up with a mum and 6 girls, and none of the girls would swear because my dad had rules. And one of the rules was guys could swear, girls weren't allowed to. So you can imagine what my upbringing was like. All those women in my life stopped me from being a swearer. No, it's not that I don't swear, but I swear very selectively, which is actually quite good. Because shouldn't swearing be used in extreme cases to get a lot of emotion out rather quickly? So if I hit my thumb with a hammer, I will swear. If the Seahawks go and pass the ball when they shouldn't, I swear a lot. But most of the time I don't swear, which is kind of good. So I thought I'd share that because I could. Now I'm going to share Desmos, and let's have a look at that guy. Our prediction is that this thing is going to be a removable discontinuity, at least at x equals 3. I know that we've got a different problem to worry about later on, but for x equals 3, that's good. Are you looking at Desmos, guys? Yeah. Okay. So y equals, oh, I better put a bracket around this just to be safe. X squared, take away 3x on the top, divided by, just to be safe, I'll put another bracket and I'll do an x squared, take away 9. Okay. Now, what's that doing at -4? Oh, it's not, it's at -3, okay. I'm interested in x equaling 3. Oh, interesting. I didn't think Desmos would do that. If you look here, can you see the value of the function as a half, like I said it was? what Desmos hasn't done, and I hoped it would, shouldn't it put a little circle there? Because technically speaking, at x equals 3, the function's not defined. So it would have been a removable discontinuity. I guess Desmos was so clever, it figured that out and it filled the hole in for us, which was a bit annoying because I'd rather it didn't. Now, can you see the vertical asymptote at x equals -3 that you mentioned earlier, which is a problem? Right? And isn't that one pretty obviously got a problem that you can't fix? It's not like a removable discontinuity where you could just pretend, I'll fill that hole in. So if someone was asking you questions to deal with this, this would be a vertical discontinuity and all the other good stuff that you could ask with that. Are we cool? We cool with that?
So
Yes.
were you able to just take a look at the two different values and
Mhm.
say, oh, that's either a jump or that's a removable? Was there a clue that gave you that idea?
The only clue that I got was because I did a factor and cancel, they tend to generate removable discontinuities. That's just experience. I wouldn't be 100% sure because there's always an exception to every situation until I saw the picture. Right, now if I'd saw the picture and at x equals 3, right, here, it was clearly broken, right? Which could harm. Then I'd say, oh, I didn't notice that. That was actually a jump. I didn't think that was going to harm, and it did. But the chances
But
are that,
What if you set conditions in Desmos?
like what? I'm not
Like-
used to using Desmos as much as you, so I'm
Well,
assuming that you know how to
can
do
you-
that.
Can you set it as a piecewise function by putting
Yeah.
like curly braces and then x equals or
I
x
have-
is greater?
I hope it does. I don't know how to do it if it does do it,
Okay.
but I know how to find out. I just don't have the time. You go to YouTube and you put in, can I do a piecewise function in Desmos? And if it's doable, someone will have done it and made a little video of it, and you can watch it and you can maybe tell us tomorrow if it's not too complicated. And
I
if,
don't remember quite how to do it, but you can do that. It's just a matter of having the right
Format.
inputs. Yeah.
okay, so it's conceivably doable, but we don't know quite how to do it right now. So watch a video and tell me tomorrow. That'll be cool. I would like to know. I just don't have the time to go looking for it because I teach 5 classes. I also have an officer, and then when I'm finished, I have to, I do all your videos, and I have to, edit them, and my day is full. And so I do like my wife, and so we do want to communicate occasionally, and I like to play with my dogs. So I ain't doing the Desmos thing. But Christina or somebody's going to do it for me, right? And tell us all about it tomorrow. God, that's very unprofessional of me, but at least I'm honest, right? I just don't want to spend time doing something like that. I should. That's very nasty of me, but I should. But yeah, it is what it is. Right. So we are continuing with our continuity questions. I lost my window because I closed it by mistake. But we're getting pretty close to the end. So again, I'm going to do a piecewise function. And I'm not going to be able to use Desmos this time because it's going to be a really messy piecewise function. Oh, I'll have to be really quick about it now. And the one that I'm trying to do is coming up. It's down at the bottom here. Yes. You use the cosine of x if x is negative. The answer is 0 if x is equal to 0. And the answer is 1 minus x squared if x is greater than 0. Now, the format that this shape takes, if you ignore that guy in the middle, would you agree that's 2 distinctly different functions either side of 0? Would you agree that this function, if it's going to have a problem, it's only going to have a problem at 0, right? And I'm going to do this fella. The limit as x tends to 0 minus of the function, and the limit as x tends to 0 plus of that function. Now, before we calculate it, if both these numbers are the same, but that number is not 0, don't we have a removable discontinuity? If both of these numbers are the same and they are 0, isn't that the function's fine, right? They've plugged the hole up for us. And if these two numbers are different, won't we have a jump discontinuity, right? So I know what's going to happen depending on the results. So let's look at the limit x tends to 0 minus. That's a left limit, which means, aren't I looking at this guy? So wouldn't the answer just be the cosine of 0, which is 1?
1, yeah.
And if I do the other one, the plus 1, isn't it this guy I'm going to use? So it's going to be 1 take away 0 squared, which is also 1. But isn't the guy at 0 not 1? So isn't that telling me I'm going to have something like that, right? Would you agree that's going to be a removable discontinuity? And we're done. And if someone tells us how to write this down in piecewise, I'll do that tomorrow, or at least an example of that, just so you can use Desmos to visualize it. Because I think a lot of these are much easier if you see the thing than if you just do the, the algebra as I've done here. Would you agree? If you could just see the picture,
Yeah.
you would say, oh, yeah, I can see that just looking at it, what the problem is, right?